So this video gives examples of how to work with the side-side angle case. We're going to jump right into this first example, and we're given a side-side angle. If we drew this, we have angle W, we have little w, and we have little r. Little r could be, WRE, it could be this bottom one, or it could be the one up there. We'll just draw it like this, so little r equals 14. So here is the scenario that we are given, and we want to solve the triangle. Now the only way to get this one started is to use the law of sines to find angle r. So you're going to set up the proportion of sine of 50 degrees over 13 is equal to the sine of angle r over 14. So the only variable on that one is the capital R. So cross multiply, take 14 times the sine of 50, divide that by 13, and you get that the sine of r is about 0.825. Since we want to find r, you're going to take the sine inverse of that decimal, and you get that r is approximately 55.6 degrees. Store that value because we might come back to it later, so I'll store it as r in my calculator. And as I look at this example, now I have two of the angles of the triangle. I'll take 180 minus the given 55 minus the stored value of r, and for angle E we get about 74.4 degrees then, which is good because the only thing left now is to find the value of little e. And to do that, we can set up a proportion again using the law of sines, and using w, sine of 50 over 13 is equal to the sine of that value of e, which we just found and probably should store. So we're going to cross multiply 13 times the sine of that value, and then we'll divide that by the sine of 50 and get about 16.35 for the length of E. Now as I check this, smallest side should be opposite the smallest angle, and largest side should be opposite the largest angle. I have that. That works out pretty well. Now the very first thing we did in this problem, though, was we used the law of sines to find angle R. We took the sine inverse, we got that 55.6 approximately, and we stored it as capital R. If I bring that back up on my calculator and I take 180 minus that value, I get r at approximately 124.4 degrees also. Now we want to check to see if this is actually going to give us another solution. So we'll take this value and the w that we're given, add them together, and notice that that is less than 180 degrees, so we are going to get another triangle. The reason why this is working is because when we took the sine inverse at the very beginning of the problem, the calculator told us 55.6. Well, 55.6 degrees isn't the only angle that has a sine of that 0.8 value that we found a lot earlier. If we look into the second quadrant, there's another angle in that second quadrant which uses 55.6 as its reference angle, and that angle is this 124.4 that I have written down here. So there is going to be another possible solution to this one. So what we'll do is we'll copy down this problem again. W is 50, that doesn't change. Little w is 13, little r is 14, but capital R could also be this 124.4. So we have that as an approximate. And by using that, capital E will change and little e will change also. So if I take the 180 minus 50 minus that value that we just found, that 124.4144, and it keeps on going, subtract those, we get that E would be very tiny at about 5.6 degrees. And then the last thing, to find this new little e, we're going to use the law of sines again. Sine of 50 over 13 is equal to this e value, the 5.6, divided by little e. So 13 times the sine of that value, divided by the sine of 50, and we're getting a very small value for e, about 1.65. Use the same checks as before. Smallest angle, smallest side. Largest angle, largest side. So there's an example of side-side angle with two solutions. It was all about that first step of the problem when we took the sine inverse and the calculator told us 55.6. Well, we had to check to see if the other angle, the one that is supplementary with that one, which has the same sine value, could work. And if it did, and since it did, that's why we have these two solutions. Next one's another side-side angle case. I could draw it out. But as I look at it, I say, all right, the only way to start solving this problem is to use the law of sines. So using that given, sine of 80 over 14 is equal to the sine of capital D over 3. cross multiply, and then divide by 14, and we get that D is equal to approximately 12.2 degrees. And if I take 180 minus that value, that's 167.8 degrees for the other potential answer. However, I see this time that the 167.8 that was found and the E, the 80 degrees that was given, add up to more than 180 degrees, so there's not going to be a second answer to this one. Instead, all we're going to do is just finish solving this triangle. So I'll take 180 minus the given 80 minus the 12.18, that stored answer that we had from before. And get 87.8 degrees. And then if we use the law of sines to find little f, we could say that the sine of 80 degrees over 14 is equal to that stored value sine of f over little f. Cross multiply to solve for f, we get 14.21. We use those checks, largest angle, largest side, smallest angle, smallest side. That's all consistent, so I feel pretty confident that my answer is correct. Here's our next example with the side-side angle. We have this given information, and like all the previous ones, we're going to start solving this by using the law of sines. So the sine of 30 degrees divided by 12 is equal to the sine of angle B divided by 28. Cross multiply 28 times the sine of 30 divided by 12, and we get 1.16. You take the sine inverse of that, and the calculator gives you an error. You can't have a sine value that's bigger than 1, so when you took the sine inverse of it, the calculator, rightfully so, gave you an error because this is impossible. If you tried to draw the triangle with this scenario, it just wouldn't work. Angle R is 30 degrees. The length of B is equal to 28, so a big value. We have those two vertices, and the length of little r is only 12. So compare this little length of 12 to that length of 28. It doesn't make it back up to that side, so this one is going to have no solution. We'll look at one more example with the side-side angle, and here's our scenario. There's some triangle ABC. We're given the length of little a equals 14, the measure of angle A equals 42 degrees, and what could the value of little b be equal to so that we get either one solution, two solutions, or no solutions? Start off by drawing the scenario. Here's angle A, there's little a, and let's say that little b is this length. And the zero solutions is the one I'm going to look at first. Because if this b value is very large, and then comparatively 14 is a lot smaller than it, I don't think that this side A would have enough to get down there. So if I said that little b is equal to, let's just go with a huge number of 80, and compared to 14 that's quite large, what's that going to do to the problem? I can even start looking like I'm solving some of the problem. Angle A is 42 degrees, little a is 14, and what if b was equal to 80? Well, we take 80 times the sine of 42, divide that by 14, try to take the sine inverse, it doesn't work, so there is zero solutions. Now let's look for another scenario. Let's look for a number that maybe is a little bit more reasonable, closer in length to 14, and say 16. So if we took 16 times the sine of 42, we cross multiply, divide that by 14, we get that the sine of angle B is about 0.7647. What we would do then is take the sine inverse of that answer, and we get the angle B is about 49.9 degrees. Now that gives us at least one solution. Check to see if there's a second solution. We'll take 180 minus that and get about 130.1 degrees. So what we're checking is, does this second potential answer add up to less than 180 degrees with the 42 we were given? Looks like that answer is yes, it adds up to 172. So if we let little b be equal to 16, then we have two solutions. Now we have to figure out how we're going to change this number up so that we get exactly one solution. So for 0 solutions, we put b equals 80. 2 solutions, we put b equals 16. I'm going to try a number less than 16. Maybe I should go bigger. I'm just going to try smaller and say, well, what if b equals, how about 10? So we would set up our proportion. Sine of 42 degrees divided by 14 equals the sine of b over 10. Cross multiply, so we're taking 10 times the sine of 42, dividing that by 14, and we get that the sine of b is about 0.48. Take the sine inverse of that, and we get that angle B is 28.6 degrees approximately. So there is at least one solution. If we took 180 minus that value, we would get another potential answer of 151.4 degrees. The key thing is that this angle plus the one that was given, that 42 degrees, have to add up to less than 180. They don't, so there is not a second solution. So in other words, when we had B equal to 10, we did get exactly one solution.